Sometimes we get a system of three equations when something weird happens as we're solving, and we go, what do we do now? All my variables are gone, and I'm left with this numerical equation. Sometimes it's true, sometimes it's not true, and then we go back and we retrace our steps. Did we make a mistake? I'm going to show you what happens here. So we've got three equations, 1, 2, and 3. I need to create, and I need to pick two equations and then add those two equations so that I eliminate one variable and create an equation of only two variables. So it makes sense that I'm going to pick equation 1 and 2 and eliminate x. Because if I eliminate x, then I'm going to have this equation over here that is y plus 5z equals 0, and I will be able to combine my new equation 4 with the existing equation 3, and then we'll be able to work that down to a single variable. At least that's my hope. So I've got equation 1, x plus 2y plus 4z equals 0. Equation 2, I'm going to take this and multiply it by -1 so that I can add the two equations. I prefer to add because personally when I subtract I do make some mistakes that aren't necessary. So I just found that adding helps me out a little bit. When I add the two together, I get -y minus 5z equals 0. Hip hip hooray. So we're going to take equation 4, -y minus 5z equals 0, and we're going to add to it the existing equation 3 in hopes that we can get this two variable system down to one variable. So I'm going to add these two together, and I'm going to see that the y's are eliminated, but at the same time the z's are eliminated. So if everything is eliminated on the left hand side of the equation, I've got nothing, which is called 0. And on the right hand side of the equation I have 0. So in essence what happened here is I've got infinitely many solutions. Two of the lines are going to be coinciding, and then when they intersect with another line, or what's going to happen is the three lines are going to end up intersecting multiple times because they all happen to be coinciding. So this right here means all the lines are coinciding. Which gives us an infinitely many solutions. Hope I said that right. Infinitely many solutions. An infinite number of solutions. So because this is no variables, yet a true statement, infinitely many solutions. So when would we get no solution? Well, let's take a look. So let's eliminate, what do we want to eliminate here? Which is the best variable to eliminate? I'm personally thinking the z's. I think the z's are the easiest to eliminate because then I can pick 1 and 2, and then I can pick either equations 2 and 3 or equations 1 and 3. So I'm going to start with equation 1 and 2. I'm going to multiply equation 1 by 2. So multiply equation 1 by 2. 2 times equation 1 gives me 2x minus 8y plus 2z equals 6. 2 times 1, 2 times -4, 2 times 1, 2 times 3. It works. Equation 2 is going to stay exactly the way it is. And now I'm going to add the 2. I get 5x minus 3y equals 5. That's my new equation 4. Now let's take equation 1 and equation 3. This time I'm going to multiply equation 1 by positive 3. So 3 times 1x is 3x. 3 times -4y is -12y. 3 times 1z is 3z. And 3 times 3 is 9. Equation 3 is 7x plus 6y minus 3z equals 2. Equation 5, 10x minus 6y equals 11. We'll combine equation 4 and equation 5 together. We've got 5x minus 3y equals 5, and we have 10x minus 6y equals 11. I'm going to multiply equation 4 by negative 2, so that gives me negative 10x plus 6y equals negative 10. So we're going to multiply this by negative 2, and it comes down here. And I get 0 on the left hand, because not only do the x's cancel out, but the y's as well. 0 equals 1. Well, 0 is not equal to 1. This is a false statement. When we end up having this situation, what happens is we've got a pair of lines, at least one pair of lines that are parallel. So all three of these linear systems of 3 are not going to intersect. So we've got 3 lines that are not going to intersect. So all 3 do not share the same point. So we've got some parallelism maybe going on here. Therefore, there's no solution. So you eliminate a variable and you have a true statement, infinitely many solutions. You eliminate a variable and you have a false statement and you end up with no solution.